Hello, my name is Taylor B. I'm going to be introducing our project. This is a project proposal brought to you by Taylor B., Cole Tinsley, and Joseph Wentz. This is for ME404 Finite Element Analysis by Sean Dawn. And our project is going to be on a sprinkler fire suppression system. To introduce our topic, we're first going to be looking at what we're going to be designing. So that is a sprinkler system, which is meant to be kept on a house in the event of a natural disaster, such as a wildfire. The inspiration this comes from the Pacific Palisades. Recently, a family had to protect their house by utilizing a similar system, and they did, in fact, they were able to keep their house from burning down. So that's why I want to design a system that can hopefully do similar things for people that are in a similar situation in the future.
Hi, I'm Cole Tinsley, and I'll be going over the operational principle or the mechanism by which our system, a sprinkler system, operates. The primary operational principle that we'll be going over are fluid dynamics, in specific, volumetric flow rate and fluid deflection. The volumetric flow rate is what determines how much water is coming out of the spout at any given time. This will affect our saturation and velocity of the water as it's deflected by the sprinkler head and the deflector at the end of the sprinkler head. This is the basis of what decides the pattern that the water will be dispersed in. Secondary principles, well, the secondary operations that will affect our system include pressure, gravity, and air resistance. Pressure, gravity, and air resistance will affect how it's deflected. Pressure might affect the deflector depending on how much force is coming out. And it also will affect the dispersion because gravity is obviously going to be pulling water down toward the ground, and that's something that has to be defined within the system. This is an image of an example of what we're trying to create on a basic point. The different color here, you can see it is determined by velocity. You can see how the water coming away from the sprinkler head decreases in velocity, and we can also see the pattern of the dispersion. We can see the individual lines of water coming off of it, and that's something that we would want to be trying to analyze with ANSYS. This is all in ANSYS, of course. Right. The part that we wanted to focus the most on, because it's the determining factor for how water is spread from the sprinkler system, is the sprinkler head. And within the bounds of the sprinkler head, what would be are the nozzle or the opening of the head where the water comes out. The radius of that hole will decide the velocity, and it'd be a part of that volumetric flow rate that is one of our operational principles. The deflector decides the shape. The the nozzle head is kind of the amount of water and the speed, but the deflector is what's deciding how that water is being dispersed. The two, the one on the left and the one in the middle in this image here, those would be spinning, and as the water hits it, it would spin and it would disperse the water in a circle. The one on the far right is not in the system that we're kind of thinking of. That one would be from a deluge system, not a wet pipe system. And in a deluge system, you have a greater volume of water. And because you have that cone there, rather than being dispersed in a wide circle, it comes off as that cone and it's more directional. The deflector, again, having to do with fluid dispersion pattern, which we're trying to analyze with ANSYS, and is kind of what we're going for in this FEA project, sorry. And pressure stress on that deflector is the main thing, is one of the main things.
Hi, I'm Joseph Wentz, and I will be going over the purpose of sprinkler systems. The purpose of any sprinkler system is effective fire suppression and prevention. It does this by spraying water around the surfaces on fire and on the fire to remove any fuel sources. There are many different types of sprinkler systems, each suited to a different purpose or environment. The most common type is the wet pipe sprinkler system, so that is the type that we will use for this project. The wet pipe system holds water in its pipes until it reaches its temperature threshold. At this point, it starts spraying water. The wet pipe system is fast acting and cost effective, but it is not ideal in colder climates. It is mainly used in homes and businesses in warmer climates.
In conclusion, our project purpose is a fire suppression sprinkler system that is designed to combat wildfires and natural disasters. And the inspiration from this comes from Pacific Palisades Fire. The system, looking at a whole, is a wet pipe fire system or fire suppression system. And component wise, we're going to be looking at the sprinkler head itself. So operation principles is looking at from the fluid mechanics side is flow rate is equal to QAV. So that's one of the fundamental principles we have in fluid mechanics. And then in order to model the fluid deflection in the sprinkler head itself, we're going to have to use ANSYS. Similarly, we'll be using ANSYS in order to model the gravity, the pressure, and the air resistance of the flow as well. Thank you guys for watching. I hope you guys have a good night.